Okay. Me holding a 5-second steely gaze means we're going to move on. And we are moving on to finally do something a little interesting with this kind of stuff. And this is, we're going to get very interesting in a second. And this is truth sets. So what's a good color for truth sets? Let's say pink. I like pink. So a truth set a truth set for a predicate, let's just call it P of X, with domain D. So you have a predicate, and D is just a collection of all things that you, or the collection of all things you're allowed to plug into P of X, is the set of all things in D that you can plug into P and get, or that you can plug into P and make a true statement. So it's everything you can plug into P and get a true statement, i.e. it's set of all X and D such that P of X is true. So that's all truth set. So we have this domain, and that's the things that you're allowed to plug into X, or plug into your predicate here. That doesn't mean that everything you plug in your predicate, everything in the domain is going to be true. The truth set specifically looking at the things that make it true. Good? If you guys know anything about functions, this is similar to the inverse map of a function. But anyway, the point is, yeah, since the truth set, so let's do some examples. So for example, consider P of X with domain. So X is even with domain, we'll use Z. And Z is all integers, positive and negative. We'll go over these in detail later. So consider P of X with domain Z. Then truth set of P with domain D, that's going to equal the set of all X in the set of all X and D such that, I'm going to abbreviate such that with the ST, such that P of X is true, right? Well, in our case, that's just set of all X, and our domain here is Z. Oh, I'm sorry. I should have made this a Z. Right here, that's what I'm saying our domain is. I didn't define D to be that. Anyway, you get my point. There we go. So this is all X and Z such that, what's it mean for P of X to be true? Well, P of X is that X is even. So this is just all X and Z such that X is even. I messed up the color scheme. But anyway, what this is this is what? So if we're looking at all the X and the integers that are even, well, you're looking at 0, 2, -2, 4, -4, 6, -6, on and on like that. And the little curly braces here, those are just used to indicate a collection of things, a set of things. So does it make sense why this is the truth set of P? Because these are all of the things in the domain Z that you can plug into P and get true out. They're all of the integers that are even.
I have a quick question.
Hit me, yeah.
In order to define the truth set, do we need to know all the values that exist within it? Like if we're only using the predicate for like a certain thing that we know the predicate falls within, do we need to define the rest of it as well? Like everything else that could possibly be.
Oh, you're saying like this dot dot dot.
Right, yeah. Can we have a dot dot dot? Like if our predicate says that like x is even and it's a multiple of 3 and it's divisible by 24 plus it's a prime or something like that. Like
yeah. No, I see exactly what you're saying. So I put a dot 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 here because in this case it's obvious. We're gonna go over and for now you guys can kind of do this if it makes sense in the homework and stuff like that. But we're actually gonna go over more. We're actually going to go over set notation later. And the way you write the set notation exactly is you say this is all things out of the form 2 times k, where k is itself an integer. And so that basically means this. So this is the precise way to write that. But for now, just let it be. Is that good? But you're totally right. You totally brought up a good point. Good? Good, perfect, cool. So that's the truth set of P of X with domain Z, but we can have other domains. Remember, domains are just things we define them to be. So we could also consider P of X with domain D equal to 1, 3, 5, and 6. So now these are the only things that we're gonna set. We're gonna restrict the things you can plug into P of X to these, just cause. So now the truth set of P with domain D, that equals set of all X in D such that P of X equals true, which is set of all X in D is 1, 3, 5, 6. Such that X is even. Red and pink. Great color scheme, Daniel. Great way to tell us apart. Anyway, so what is this? What are all of the things in 1, 3, 5, 6 that are even, that you could plug into P of X and get true?
Six.
Just 6, right? When they're finite, we can go through them. Like 1, okay, let's plug 1 to P of X. 1 is even. That's false. So it's not going to be in the truth set. 3, plug it into P of X. 3 is even. That's also false. It's not going to be in the truth set. 5 is even. Also false on the truth set. 6 is even. Hey, that's true. So 6 is the only thing we can plug into P and get a true value. So that's the only thing in the truth set. That's all this means. Any questions on this?
Do you think we'll work with more like limited truth sets like D is, or do you think we'll work with more like boundless ones like all integers?
Little column A, little column B, my friend.
A little bit of both. Okay.
Shake it up. Yeah. No, it's gonna be cool. It's gonna be cool. Because I mean, one of the coolest things about math is infinity, right? I mean, so I would be doing you an injustice if I didn't show you any math. You know, that would be like having an MCU without Spider-Man. I love Spider-Man. Yeah. So I'll do one more example, to show you something important, and that is consider Q of AB. So we're looking at this guy now, right? With domain D equal to all pairs of people in my immediate family. And so I'm an only child, so all pairs of people in my immediate family, that is me and my mom. There's me and my dad. There's my mom and my dad's another pair. Am I missing any? No? Yes? I don't know. I think someone might be thinking, crap, does order matter?
Would you switch it around so then it's mom and me and then dad and mom?
Yes. Order matters, which is why we're actually going to end up defining these as ordered pairs. But order does matter. So this is mom and me, and then there's also dad and me. It's like a children's book. And there's dad and mom. All right. So order matters very much. Why does order matter? Well, let's think about plugging one of these pairs into Q, right? Q of me and mom, saying I am my mom's parent, that's false. But Q of mom and me, saying my mom is my parent, that's very true. So the order definitely matters. Gosh, I feel real comfortable putting the kid-friendly blocks on YouTube this time when I put this video out. Yes, so order matters. Now let's look at truth set. Truth set of QAB with domain D. And so that's going to equal set of all. So now the things we plug in, things in our domain, they're not just an X, but they're actually a pair of things, maybe like that. So instead of all A and B and D, such that Q of AB is true, which is just the set of all A and B and D, such that QAB says A is B's parent. So, looking at, I'm gonna make a nice big one here. Looking at D, right here, right? What thing's gonna plug in, which of these pairs is gonna plug into Q and get true out? Which one of these is the first entry a parent of the second entry? Once again, it's finite, so we go one by one. Me and mom, plug that in. Am I my mom's parent?
No.
No, I'm not. So that's not going to be in. How about me and dad? Am I my dad's parent?
Nope.
Mom and dad? So my mom my dad's parent?
Definitely
Game of
not.
Thrones, she's not.
Yeah.
No. Mom and me, is my mom my parent?
Yeah.
Yeah. So mom and me goes in here. Mamma mia. And how about dad and me?
Yeah.
How about dad and mom? Once again, Game of Thrones, no. So, the truth set of Q of AB, so this predicate, with the domain, my immediate family, is going to be this. Now, if you use your immediate family, you'd have pairs of sisters and parents and things like that. If you use a bigger family, you'd have aunts and like your aunt and your cousin or like whatever. Or if you said D is all people in the world, you'd have to then put all pairs of people. You have to put Charlie Sheen and Martin, or Martin Sheen and Charlie Sheen. You have to put John Voight and Angelina Jolie. You have to put like Malik and Michelle Obama, all those things, right? So, the point is, so the point is the domain just affects what we're looking at, just the scope of what we're looking at, and the predicate tells us this thing that will become a statement when we plug it in. Any questions on truth sets? Good. Well, you can bet your life that you're going to see truth sets in your homework this next week coming up. But all right, we're moving on. 2. What's next? Aha, this is good. Oh, by the way, a truth set can be empty. I should mention that, right? So truth set of M of D with domain 3. Let's just say that, right? This equals set of all D, whoops, you don't know that symbol yet, D and D such that M of D is true, which is set of all D in 3 in the set that just contains 3, such that M of D is 3 squared plus 2 equals, or sorry, D squared plus 2 equals 6. Is there anything in this set that you can plug into M and get true out? I mean, the only possibility is 3, right? Because it's the only thing in the set. And then you plug 3 in for M, you get 3 squared plus 2. That's 9 plus 2, which is 11, which is in 6. So this is just empty, which you write as that. So sometimes the true set's going to be empty. Sometimes not. All just depends. Any questions?